Okay, to continue, we're going now to solve for the station of PVC. So the station of PVC will be equivalent to, that is actually 141. So that is the station at the lowest point, 141 plus 0, 0 minus the distance of the lowest point towards PVC. So that is 1 plus 22.5 station, because this is 122.5, so feet. So uh there will be, so this will be all over 100, per one station is 100 feet. So therefore this will be equivalent to 1 plus 22.5. So therefore this will be equivalent to 139 plus 77.5. Now we move on to PVT. So for PVT, we are going to, for PVT, we are solving for the station at PVT. We are given with the elevation of PVT, which is actually equivalent to, this is 274 feet. So if we are given with the elevation of PVT, we can make use the parabolic equation. This parabolic equation, we can make use of this. Our elevation at PVT is 274. Our x here, which is the distance from PVC, the distance of PVT towards PVC, that is actually our L. So our x here is equal to L. So therefore, using this equation, y is equal to ax squared plus bx plus c. We have 274 is equal to, the value for a we have computed a while ago, 0.000102 times our L, our x, which is L, so L squared, plus b, which is equivalent to negative 0.025, then multiplied to our L, to our x, which is our L, so times L, then plus our C is the elevation of PVC, and that is, we computed that one, which is equivalent to 271.53. So therefore, if we try to simplify this one, we get the value for L, which is 320.624 feet. So we have now the value for our L. So therefore, if we try to have now the station at PVI, so we can have now the station at PVI. So therefore, the station at PVI, station of PVI. So that will be actually equivalent to the station of PVC plus L all over 2. Because if we're going to have the sag curve, so this will be PVC. This is our PVT. So we have our tangent of the initial and final grade. So this will be our PVI. So actually, length all over 2, because that is on the midway. So approximately, so this is L over 2, L over 2. So this will be, the station of PVC is, we have computed a while ago. So that is 139 plus 77.5, then plus our L over 2, because our L is 320.624, or that is divided by 100, so that is 3 plus 20.624 all over 2, and this gives us 141 plus 37.812. So now, what will be the elevation of PBI? So the elevation of PBI will be, is equivalent actually to elevation of PVC plus the initial gauges of 1 times L all over 2. So we have here 271.53 minus 0.025 multiplied to 320.624 all over 2, and this gives us 267.52. So we have now the answer for our problem. Okay, the second problem is an existing tunnel needs to be connected to a newly constructed bridge with a sag and crest vertical curve. The profile view of the tunnel and the bridge is shown in the figure. Develop a vertical alignment to connect the tunnel and bridge by determining the highest possible common design speed for the sag and crest. Having an equal tangent, vertical curves needed. Compute the stationing and elevation of PVC, PVI, and PVT curve points. So we have here a tunnel. So the curve is a combination of a tunnel and a bridge. So that's one if you're going to observe based on our figure. So we have here a tunnel and you have a bridge. So this is now a combination of a sag vertical curve. So you have a sag vertical curve and you have a crest vertical curve. So this one, for this illustration, if you're going to observe, the station on PVC for the crest vertical curve is you have 0, 0. For the station at PVT, we have 12 plus 0, 0. The elevation here, the elevation of the tunnel is 100 and the elevation of the deck is 140. So from the tunnel towards the bridge deck, that is 40 feet. So therefore, based on our illustration, we could have that the gist of 1, at the sag vertical curve is equal to 0%. So we have here 0% for the initial grade. And for G sub 2, for the crest vertical curve, that is actually equivalent to 0% also. So that is our final grade for our crest vertical curve. So we have to obtain the highest possible design speed. So for this one, you have to take note that the PVC, the PVT of the sag vertical curve is the PVC of the crest vertical curve. So meaning to say this is the PVC of the sag vertical curve. This is the PVT for the sag vertical curve. And this is also the location of the PVC of the crest vertical curve. And this one is the PVT of the crest vertical curve. So we have to take note that for this one, we have established that our G sub 2 for the crest vertical curve is equal to G sub 1 for the sag vertical curve, which is equal to 0%. And we have to take note that therefore our A sub S, which is also equal to A sub C. And we have to take note that this can be written as our A. So since the distance from the tunnel towards the bridge is this one is 1,200 feet. So this is station. This is actually the length of this is 1,200 feet, or that is 12 station. So therefore, since we have we have already established some of the parameters, so we can, since we have the tunnel and the bridge is separated by 1,200 feet, so we can have the equation that L sub S, the length of the sag vertical curve plus the length of the crest vertical curve, is equal to 1,200. And we can have an equation for the final offset. So the equation for the final offset for the sag vertical curve, which is the final offset for the sag vertical curve and plus the final offset for the crest vertical curve, actually is equal to 40. So 40, since the elevation from the distance from the tunnel towards the bridge is equal to 40. So therefore, for our final offset, the equation is actually AL all over 200. So this one is for the sag vertical curve, then plus ALs of C for the crest vertical curve over 200 equal to 40. So therefore, we can rearrange this one. This can be written as A all over 200 times L sub S plus L sub C, and this is equivalent to 40. We have to take note that L sub S plus L sub C is actually equal to 1200, so this can be written as A all over 200 times 1200, which is equal to 40. So therefore, from here we can simplify. The value for A here is 6.667%. So now we are going to find the value for K. So from our equation, L sub S plus L sub C, which is equal to 1200. So we can have, wherein our L is equal to K times A. So we can substitute this one, the value for L. So this will be case of, from this equation, case of S times A plus case of C times A. This is for the sag vertical curve and crest vertical curve. We simply have denoted A sub S and A sub C equal to A, because a while ago we have identified that A sub S and is equal to A sub C, which is equal to, can be written as our A. This is 1200. So therefore, if we try to substitute the value for A, which is 6.667%, we can simplify our equation as case of S plus case of C equal to, this is divide to 6.67, so this gives us 180. So now we are going to find the highest possible design speed. So that we can get the value for the possible design speed, we have to identify the value for our K. A while ago, we have the equation that case of case of S plus case of C is equal to 180. So now we are going to make use. Case of S is for the sag vertical curve. Case of C is for the crest vertical curve. So we're going to find from table 3.2 the value for K for the crest vertical curve. And in table 3.3, we have to identify the value for K, which is for the sag vertical curve. So make sure that once you find the value for K, you are going to identify a design speeds of the same value, so that we can identify the value for K for the sag vertical curve and the value for K for the crest vertical curve. So make sure once you identify the value for K for sag and for the crest, they must be equal to 180. So which means that, for example, you try to identify that the value for, you try to choose that the value for the design speed, assuming is 45. So if that is 45, so the 45 here is 61. Then on table 3.3, for the sag vertical curve, you have to identify again your K. So 45, we agreed, we tried to have the value of 45. So it is 79. So 79 plus 61 is not equal to 180. So again, try to look for another value for K. So let's have 50. So if we're going to have 50, the value for K for the sag vertical curve is 96, and for the value for K for the crest vertical curve is 84. So 84 plus 96, it will give us 180. So which means that the value for our K and S are 84 and 96 respectively. So that will be the design speed now is 50 miles per hour.